Okay, hello everyone. Welcome to another Wolfram Language Design Review as we get ready for the first code freeze for version 13.3. And we are talking about some compiler things. Which should I look at first? Sequence type.
Look at kernel evaluate first.
Okay.
Right. So this is in some ways a sort of different version of something similar to kernel function. So essentially what kernel evaluate does is, the simplest usage is it just provides a block of code that will get run in the evaluator as opposed to in the compiler, and you can use it inside the middle of your compiled code. And the other usages are just so that you can refer to variables from the compiler in your evaluated code.
Right, but why is that thing that looks like a function and kernel function? Let me remind myself how kernel function works.
Right. So kernel function is for, is essentially a subset of kernel evaluate.
You have to pass arguments to the kernel function, whereas
as
you
a
have
sub-value, as sub-values.
Yes.
Yes.
What does kernel function do? By the way, why on earth is that signature for kernel function not described up here?
What do you mean that signature?
Oh, no, I'm sorry.
The type is outside. Yeah.
Type is outside. Right.
Okay, so kernel evaluate is taking its arguments, is evaluating that expression, having entrained certain variables.
Correct.
Well, when you say
Right.
kernel function there, can you give a pure function as the kernel function?
Yeah.
Yes.
Sure.
That's why these are pretty similar. But I think there are a lot of uses where kernel evaluate is a lot more readable.
Yes.
So an example of a kernel function. So here's, for the one argument kernel evaluate, you could imagine writing something like, absolute time open close, or I don't know, something with, something that doesn't take any arguments, but where, you still want to run it in the evaluator, when you run the compiler, if that makes, or when you run the compiled code, right? The multi-argument cases are basically if you want to, import variables. It's basically like if you want to say, here's my compiled program, but this part right in the middle here, I want to evaluate that, not compile it.
I'm actually very confused here. How does the scoping of this arg work here?
So the outside arg, so it's okay. Right. So basically arg, that it's an argument to the function that you're compiling.
Right.
But that outer arg, you could also imagine that being like a module variable or something like that. It's just any variable thing.
Yep.
Then kernel evaluate is kind of like a scoping construct itself, where you basically say that the thing at the beginning is a bit like a with spec or something, where you're just saying, like, here's the list of variable, or maybe like a module spec. You're saying, here's the list of variables that I want to capture from the compiler environment and, make available for the evaluated environment.
Yes. But right, but it's kind of an anti-scoping, because what it's doing, it's a capturing, not a scoping.
Yeah, it's a capturing. Yeah.
The capture, right.
Are you sure the argument order is right then for kernel evaluate?
I think it should look like with, or like any of those scoping things.
Yes.
That's the concept. Or even like function. Function also takes the,
yeah, but remember, those are not capturing.
First.
Those are not external captures. In other words, kernel evaluate, and what you're doing is the name of the first argument is in the global environment. All those other things like function, the name is meaningless. It's a local, it's a local variable.
I guess so. Yeah.
So this is really a different thing. This is a capturing the name.
Well,
The
but
heck
for
is this
example,
like?
it's actually quite similar to function, except that the value of the function comes from the environment as opposed to from the argument.
Right.
But it actually, on a, this doesn't matter that much, but on a technical level, I think it does use with. So like it uses like expression replacement, like function or with would.
Right. And inside its body, it's lexically scoped.
But how does it get? Okay, I'm now totally confused. If I say, for example, let's say I just say, I say kernel evaluate of, I've got something that says x plus kernel evaluate of x comma x squared.
By the way, are you in an old? I think you're not in a 13.3.
Yeah, I'm not in a 13.3. Yeah, this is,
Okay.
I mean, if I
I
do
would
that,
recommend you try and run it yourself because it will compile quickly. But
okay,
I mean, so assuming that x is some variable in the local environment. I mean, first of all, obviously you would never actually need to write that because x
yeah, x
squared is
squared
defined in
compiles.
compiler. But yeah, I mean, so basically it's saying x plus, and then here's an evaluated block, which I think was the original name of this, was evaluated block. And we're just saying that basically x needs to be available in the evaluated block.
Yes, I understand. But what is different between this and function, for example, is function specifically doesn't care the name f. Okay, so look.
Sure, I understand. I understand what you're saying. I mean, arguably, there's some things with block where it is aware of the things outside of it, if that makes sense.
Yes, I understand.
Especially inherited block, although that's not documented, I don't think.
Right. Okay, so the point is, and why is it that it needs to reference, that it needs to mention these variables? Why can't it just see that there are variables there and use them?
It probably can do sort of wizardry to see what variables are used, but it's iffy. And like, for example, if you have the symbolic expression x squared, but x is not actually a capture variable, like there are all sorts of weird, like for example, suppose it sees that you wrote, full simplify of x squared, over x squared or something like that, right? So it doesn't actually matter what the x is. Suppose that there's no compiler variable called x in scope. That would probably correctly be identified as an error, because it would say, oh, well, I see that you use this variable x in your evaluated code, but I actually can't capture any x from the compiler environment, right? Does that make sense?
Yeah. Surely we should say in the kernel or something. In the
we debated that. Yeah.
Yeah, so in kernel, so I mean, the original thing we wrote was like Wolfram language kernel, but then kernel function says something slightly weirder. It says like the Wolfram engine kernel,
Right.
Which is probably a little bit wrong.
Yeah.
Then there's like,
you've got kernel function open.
Okay.
Right.
Another one is using the term evaluator, which is used in one of the examples, I think, for kernel function.
Well, but maybe we could say the kernel evaluator to be evaluated in the. Why don't we say in the main Wolfram language kernel?
That sounds like there might be other kernels. And also, if you're doing this in some parallel evaluation, then that's
all right, okay.
confusing.
Well, I mean, what do we say that the compiler is evaluating in?
Raw native code. I don't know if we said that anywhere.
I think we just say compiled code in a bunch of places.
Right.
Like we have, for example, things that say XYZ is suitable for use in compiled code.
I think we should say Wolfram language kernel here. I think Wolfram engine is its own branded headless animal.
Fine.
But let's go back to this, okay?
Yeah.
So kernel evaluate look, I mean, oh my gosh.
We have used, and I think you wrote these, like look at function compile. That talks about use the Wolfram engine rather than being compiled into low-level code. Now we can change this.
Well, wait a minute. Function compile.
Right, so look at function compile and look at the notes. There's a note. Yeah, that one, there's one there.
Where?
Sorry,
Oh, it should directly use the Wolfram engine. I think we should change that. Should directly use the Wolfram language kernel.
I can go and make changes like those if we agree on the.
I think we agreed about that. By the way, these should be.
Can I just say, but do we actually use kernel? Is that our terminology?
Well, yes, and look at the name of this function.
That might be true. Right, Wolfram language kernel. I will make changes like those.
Okay, all right. So let's just talk about this capturing thing, because I think it's I would say something like captures the variable x from the compiled code to be used in the evaluated code.
So I'm not necessarily opposed to that. One thing is that I think the word captures sounds a lot like closures, which is not really what this is.
This is. But let me just go through again what this really is. This is saying, okay, let's review why it cares, right? Why can it not just lexically see there's an X here and there's an X? I mean, you've already declared every variable that's here. Is it true that every variable is declared?
Yes, in the compiler, yes.
Okay.
But
Right,
but
so-
look,
yeah.
write out this example, okay? So write out, you imagine if your compiled function, just make a function so it's clear this is the whole thing. It doesn't take any arguments. And then kernel evaluate of I don't know, here's a dumb one, simplify of x over x, close bracket +2.
Yeah, you don't want automatic capturing. You don't.
Well, the bigger problem is that okay, so that obviously returns a 3, and it needs, but now if you imagine writing something on another line where you just write kernel evaluate of x +2, the problem is it can't. I would argue that kernel evaluate of x +2, like you kind of want that to fail. You don't want it to just sort of say.
For now, until we can compile symbolic things.
Well, we can. If you did typed inert expression, it would be completely fine.
Right. That's true. Right. That's true. Which also makes it really confusing. So I mean, the point being that I think it is right now, basically, you tell it what variables you want, and if those variables don't exist in the compiler, it fails. If it were detecting it automatically, at least right now, it wouldn't be able to have any failure case like that, because we would just have to assume, oh, I bet that's just a variable that's meant to be symbolic.
Right.
And I think that'll lead to really weird stuff.
Yep.
Okay, hold on. So the basic issue is.
But we can probably, I think this is a bit defensive, because later we can always add, inferencing like that to the one argument case.
Right.
But I think it would be a mistake to add broken reasoning like that to the one argument case that we can't get rid of.
Yeah, fine. I agree. But I mean, then, I mean, I think here we should say something like,
Makes X available for use in Expr.
that's better. Makes the compiled variable.
Well, isn't that what passes means?
Yeah,
I
but
guess, although passes maybe implies that it's like passing it to a function. which
yeah,
means
passes
like,
it by
what
value.
function?
Passes usually is by value, right? Which is not what's happening here. It's not passing X by value. It's making X, as you say, available.
Well, actually, I think it is passing it by value because actually, I'm trying to remember now. If you actually, Tom, do you remember you can't set X inside of the
No,
kernel
no,
evaluate, right?
you can't.
Okay, yeah.
You should say
So it
that.
is basically
say
passing
that.
it by value. Yeah, that's a fine note to have, but it's right.
Okay, so
Capture would be fine. Captures the compiled variable X for use in compiled code. For use in evaluated code.
for use in the evaluation of Expa.
Yeah, fine.
Shall I just make these changes?
Yeah, do that. Do that. Great. Perfect.
So to be clear also, right. So what this actually turns into is it turns into like a with block.
Right.
Where, all the variables you declared are, set
Captures
to whatever their
the
compiler
compiled
value is.
variable. How about captures the value of the compiled variable X to use in the evaluation or for use in the evaluation of
Fine.
Okay, and while we're at it, I might as well just add the note that says
Yeah, expert cannot modify XI or something.
Right. Well, I mean, by the time it's sort of implied by this, but it should say
Yeah, it should say it anyway.
It doesn't hurt.
right. The evaluation of Expa cannot modify the value in kernel evaluate. Evaluation of Expa cannot modify the value of X. Okay. All right. Okay. Okay, I get it. This makes sense. All right. Should we look at sequence type?
Sure.
Sure.
This seems.
This is a lot more
kernel evaluate.
mind-bending.
Sorry, what's that?
No, what were you going to say about kernel evaluate?
No, I mean, I think I'm buying into the fact that kernel function is the the wrapper that has its variable values passed in. Yeah, it all makes sense.
Good. Good.
Yep.
And I was saying sequence type is a lot more mind-bending. So.
Oh dear.
Yes.
Then kernel evaluate.
For sure. So this is a type construct that's analogous to sequence. So it's basically the way you do varargs functions in the compiler.
Okay.
Do you want to open for all type? That might be related.
Right. So basically, if you look at like the first example for all type, maybe, or I guess the usage lines too, but okay, right. So if you look at that first example, right? So here, T, the variable T just refers to like a single, it's like a blank, a single blank. It's like, this is some type. Sequence type, if you look at the first example of that, on the right-hand side, you can say sequence type T. And that basically means that it's like saying that it basically implies that T is actually a triple blank. And, right, we can have any, you can have whatever sequence of type
called blank type.
So one of the things we've talked about doing, but which is a bigger project that is kind of theoretical right now, is the idea of trying to unify a bunch of type syntax stuff with patterns. There are some arguments. I think there are various reasons it would be nice. There are also some problems with it, like that there are lots of pattern constructs that just fundamentally don't make sense as type constructs. So it'd be kind of a fake subtype,
and vice
sub-pattern.
versa, probably, and vice versa as well. So
maybe, yeah. But so, right. So at least for now, types are not trying to look like patterns.
But look, when you do down value compilation, you're absolutely going to want to take, configurations of blanks and turn them into types, aren't you?
Well, yes, that's probably orthogonal. That's a different thing,
Right. That happens internally, but it's not exposed.
Okay. All right. Sequence type then.
Right.
So that's a type.
Maybe look at the first example, because otherwise it'll be really hard to understand.
Yeah, right.
Not that the first example is particularly easy to understand. So basically that type, that type represents that it's a machine integer followed by some sequence of things represented by T, and it returns a machine integer.
Yes. Then
you see the definition. There are two definitions that were used for this function, right? So one of them, right. So the first one, basically, it's like a fold. So it's taking that first integer and adding it to var_args add of the rest, right? And there's the base case when you give it a single integer. In that case, the sequence type is, I think it's 0 essentially. And then, right, and then now you have a var_args function. And you see that implicitly.
I don't understand, why is this hard to understand? And that it's a sequence type means, I mean, in terms of type theory, I understand that it's in terms of, symbolic expressions, why is this complicated? I mean,
maybe it's not. If you don't find it complicated, then that's great.
Well, maybe I didn't understand it. I mean, it's just a type that represents a sequence of what? Well,
of anythings. And then it's implied, you see in this example, it implies that it has to be a machine integer, because you see that when it recurses, there won't be a usage. If you had a float in the middle of it, or a real or something, right, then there wouldn't be any usage of this var_args add function, which matches that signature.
Yes.
With the real in the first argument.
Right. Because the function declaration here is using that type. Yeah, I mean.
Okay, if you find this easy to understand, then that's great.
I think maybe I'm totally confused, but it just seems.
I don't think you are.
Okay, well, I think this is fine. I mean, looks good to me.
Great.
Is this? Are you guys putting this stuff onto guide pages appropriately? And all
yes, I'll do that. But I just wanted I don't want to do this and then find we rename it. And I'll unfuturize these and do appropriate knitting and stuff.
Okay, I'm going to push back these. I'm going to do an update to push those files back.
Fantastic.
And
right.
I think we are done.
I'll take care of that, and I'll look at the other stuff that you have as well. Okay.
Sounds good.
Right. And
Great.
okay. Okay.
Good stuff.
Right.
Okay.
Thanks.
Cheers,
Okay.
everyone. Okay.
See
Bye.
you. Okay.
Bye.
Bye.
Bye-bye.
Thanks,
Bye.
Tom.